Hello guys, this is Ittehad from the Roots of Unity with the third and last video of quadratic equations. Let us start with the discriminant b square minus 4ac. The discriminant b square minus 4ac represents the nature of the quadratic equation. This means that we can identify whether the root is real and distinct, whether the root is real and equal, or whether the root is complex, which means whether there are two roots or one root or no root at all. Now, let us first check out where does this b square minus 4ac come from. Let us go back to our general formula. X is equals to minus b plus minus root over b square minus 4ac divided by 2a. In this formula, b square minus 4ac is inside the square root. Now, if b square minus 4ac is positive, there will be two values of x indicating two roots. We already know this. But if their b square minus 4ac is equals to 0, the root over part will be eliminated since root over 0 is equals to 0. Therefore, the plus minus part will be eliminated, giving us x is equals to minus b divided by 2a. That means there can only be one root. Now, if b square minus 4ac is negative, the result of the equation will be complex since there is negative value inside the bracket. Thus, we can say that if b square minus 4ac is greater than 0, the roots are real and distinct. If b square minus 4ac is equals to 0, the roots are real and equal. And if b square minus 4ac is less than 0, the roots are complex. We can use this before sketching a graph to see whether there are any roots of the equation, because there is no need to solve an equation and waste our time finding that the roots are complex. This is the other method I was talking about in my previous video while sketching a graph. Now, let us see how we can solve a linear and a quadratic equation simultaneously. After solving a quadratic and a linear equation simultaneously, the values of x's and y's we find will indicate the points where the line and the curve touches or cuts each other. By using the example of the line y minus x is equals to 2 and the curve y is equals to x squared plus 3x minus 1, I will explain you the procedure on how to find the solutions or the intersection points of the curve and the line. Now, let us check out the procedure first. In order to solve these, we will use substitution method. We will make y subject in the linear equation and then substitute this value of y in the quadratic equation. Simplifying one step further, we will find a quadratic equation with only one variable, x. Then we will solve this equation to find out the points of intersection of the line and the curve. This brings us to the very last part of the chapter, how to solve equations that reduces to quadratic equations. Our first step here will be to bring the equations in the form of a quadratic equation ax squared plus bx plus c is equals to 0. I have used two examples to clear out the conception. Expressing the equations in the quadratic form gives us the equations e to the power x whole square plus 2 into e to the power x minus 3 is equals to 0, and for the other equation 2 into 2 to the power x whole square plus 4 into 2 to the power x plus 2 is equals to 0. Now we can substitute e to the power x and 2 to the power x with another variable such as a, and then find the solutions of a. After finding the solutions of a, we will replace a with the original variables and thus find the solutions of our equation. That was all for quadratics. It was easy, no? If you guys have any questions regarding this chapter, leave it in the comment section below. I would love to answer your questions and clear your conceptions. See you next time in some other videos. Like, subscribe and share, guys.